Okay, so hey everybody, this is Mr. Bellis. Video we're going to talk about right now is dealing with characteristics of quadratic equations. So being able to know what the vertex is or how to get the vertex, being able to know its x-intercepts, its y-intercept, and then the keys to why all of those things are important for us. After the initial little talk about reasons why we might want to know some of those things, then we're going to do some of the more difficult technical math stuff. So here we go. Here's a couple of few pictures for you right now. So any parabola that I draw out here, whether it's pointing down or it's pointing up, has key things. It has places where it crosses the x-axis, it has places where it crosses the y-axis, and then it has either this case as a maximum point, or this case right here, that's a minimum point. All of those things we can get from the equations that we can also look at from the graph. So first off, why would we want to do that? So I'm going to take a look at this problem right here, and we're going to call this one the lemonade stand problem. Lemonade stand, we're going to make it really basic. Little Jenny is producing lemonade. She wants to make lemonade and sell it outside in front of her house. Well, mom and dad go, that's great. Where are you going to get the lemons from? Where are you going to get the cups from? Where are you going to get all that stuff? And that's what happens right here, is that point. Those are, you can see, this curves the lemonade stand function based on how much she's going to produce, how much lemonade she's going to make, and how much money she's going to have come in. We have this point right here, and that point right there is all of her startup costs. Every business has to have a startup cost. You got to be able to raise some money to buy the goods that you need to be able to start producing it. So that's her startup cost, and I don't know how much it is. It doesn't really matter, but know that she starts off in the negative. And then over time, she starts producing this lemonade, and if she's producing it, then she's selling it. And sooner or later, she's going to hit this point right here, and that's called a break-even point. That's where the amount of money that she's had come in from what she sold balances out the money that she spent from her startup costs. And then if she keeps producing this, and remember this is production of it, not necessarily sales, but producing it. So she keeps making more and more and more lemonade. Maybe out there on her little table that she has out there, she's got all of these cups of lemonade, and nobody's buying it anymore. So she overproduced. And if she overproduced, that lemonade is just going to go bad. So she spent a whole bunch of money making this extra lemonade that she's not going to recoup from. So at some point in time, she's going to break even again, where all of this right here, all of this is where she made some sort of profit. Okay? What the nice thing about this is right here, right there, that's the goal for most businesses, is where can they maximize their profit? Where can they get the most out of it? So how does this play a role in it? Well, as you can see in this quadratic equation, these two places are the x-intercepts, and in this case, they mean the break-even points. This case right here is the highest point in terms of the problem. It's where they're going to make the most money. And this point right here, which is considered the y-intercept, is where their startup costs are. Give you a quick little another one right here. Hopefully this makes sense. And here's our axis, and I'm going to do this one right here. And we're going to call this throwing a ball. So there's a person who throws a ball, and they release it from right here, because that person's probably about that tall, and they throw it from up in the air. And the ball travels, and this point right here would be how high the ball goes. This point right here would be where it hits. Good deal, so that's its height, how high it is. This right here, the y-intercept, is where they release from. And this point right here, which is the other x-intercept of the parabola, really doesn't have any basics to it. It's just that the equation has to have balance. Technically, if I follow the path of the ball backwards, it would be like going back into time. Okay? So you kind of go back down to the ground there. But this one really not important in terms of the stuff that we're looking for on this particular problem. Okay? Okay, so let's actually do some math. So the first thing I want to look at right here is three different forms. So y equals x squared plus 7x plus 12. This is called the standard form of an equation. Y equals 2 times x minus 6 squared plus 4. This one's called the vertex form of the equation. Vertex form. And y equals negative 3 times x plus 2 times x minus 8. This one is called, we'll use two words for this one. It's either called the factored form, because it is factored, or technically it's the x-intercept form. So here's the deal. Depending on which way the equation is given to you, it's going to tell you some different information. Remember, these are the four critical points that we want to know. We want to know this, the y-intercept, these, the x-intercepts, and this one, the vertex. And if we can get those things, it'll help us understand about application problems. Okay, so the first one in standard form means there's no parentheses at all. Each term's individual. They can be pluses or minuses, whatever it is. It doesn't matter. But this number right out here is the y-intercept. And the y-intercept simply means where it crosses the y-axis. And we know that it crosses the y-axis at 0, 12. Because if I plug 0 in for x, that goes away, and that goes away, and that's left over. Okay? So if I see a standard form equation, right, no parentheses, no grouping, stuff like that, then I know it's the y-intercept. Okay, vertex. This one's called vertex form. And well, how I get the vertex is I look right in here. Vertex is going to be a coordinate. I look right inside this parentheses. First off, how do I know that it's in vertex form? Vertex form will always have the x with a plus or a minus right here, yes? And it could be plus or minus nothing, but plus or minus right in here, and then squared, okay? And then we'll have something else over here on the side, and it still could be plus 0. It could just be away, but it's going to have some plus or minus that's outside of the parentheses that are being squared. Okay, so if I have that form, then I know automatically that the vertex is at the opposite of whatever this is, 6. So if this is a negative 6, we know it's at 6. And whatever this is, 6, 4. And you could quickly take on your graphing calculator, go ahead and graph those. X squared plus 7x plus 12, you would see that the y-intercept actually is 12. You can graph y equals 2 times parentheses x minus 6 squared plus 4, and you would see the vertex is at 6, 4. Okay, so this last one, what does it tell us? Well, if this one told me y-intercept and this one tells me a maximum or a minimum, this one probably tells me x-intercepts, and that's why we call it x-intercept form. And x-intercepts are going to be found from these two things. So the first one is, again, what makes it a 0? So negative 2, 0. That's one of the x-intercepts. That's where it's going to cross the x-axis. And the other one is going to be at 8, 0. So again, it's whatever number you plug into here that's going to make that the opposite of the number that you actually see. So negative 2, 0, and 8, 0. Okay? How do I know that it's in factored form? In factored form means that you're going to have the x in a set of parentheses and another x in a set of parentheses. Remember, you have to have two x's that are multiplied together to get an x squared, right? And it's going to look just like that. Okay? This number out in front doesn't affect that it's in factored form, doesn't affect where it crosses the x-axis, just affects whether or not the parabola is skinny or wide, and whether it opens up or opens down, okay? And we know from some basic stuff that if there's a negative out in front of all of these things, then it opens down. So negatives make the parabola open down. Positives, it will open up. Good deal. Then we look at this number right here, which is the coefficient of it, and the bigger the number, the skinnier it is. And technically what it means to be skinny is that it grows really fast. That's why, right? This one grows really slow, like that. So the bigger the number in front, remember, ignore the sign. The sign makes it move up or down. But the bigger the number in front of it is going to make it skinnier or grow faster, skinnier or steep. Where slower or wider, like the leading coefficient for this one might be like 1/5. It's going to really be slow growing on that. Okay? So some of the things I'm going to talk about right now is, after we know those forms, there is mathematical ways to be able to go between those forms, and I'll give you a couple quick ones right now. So let's say we had y equals x squared minus 6x, and let's go minus 16. I can look right at this one right now and I could go, hey, I know that the y-intercept equals 0, negative 16. I know where it starts on the y-axis. And some of you go, hey, but I remember we've worked on some factoring things, so I could rewrite this as y equals x minus 8, right, times x plus 2. You're like, oh yeah, negative 8 and positive 2 gives me negative 6. Awesome. And negative 8 times 2 gives me negative 16. So if I can write it in this, that's x-intercept or factored form, which means the x-intercepts are 8, 0, and negative 2, 0. So now I know not only where it crosses the y-axis, I know where it crosses on the x-axis. And then I'm going to do this, and stay with me on this one. I'm going to move this into vertex form. I'm going to move it into vertex form. And this is going to be a little tricky, so stay with me. I'm going to do a process to get it in vertex form. A process called CTS, completing the square. I'm going to make this thing a perfect square, and this is how it works. So again, remember, completing the square. And you're like, what the heck? Well, right up here, my x is isolated in a square. So I'm going to try and get this thing isolated in a square just like that. And then I'll have maybe a number in front, maybe something out here. It just depends on what my problem looks like. Here we go. So this is what completing the square looks like. I start in standard form, x squared minus 6x, and I move that 16 over just to the side. I'm like, just chill out over there for a little bit. Okay? Then I take whatever this number is, right in front of the x, whatever the linear term is, and I cut it in half, which is negative 3, and I put in a little square box on the side. That's just going to help me remember some things. Okay? And then I square it. Whatever's in the square box, I'm going to square. So now I've got y equals x squared minus 6x, and I still got that minus 16. So you guys tell me, what is the square of negative 3? And you guys are like, hey, it's plus 9. Awesome. So I'm going to write plus 9 right here. And you guys know I can't just randomly throw a new number into an equation. That would make the equation no longer true. So what I'm going to do is, on the same side of the equation, is I'm going to subtract 9. So I added 9 here, I subtracted 9 there. And the balance of that thing means that it canceled each other out. Remember, there's my equal sign, so I did that to the same side of the equation. So it's like I put on 9 pounds on a seesaw, but I took it off on the same side. It doesn't affect it, just affects the way it looks. Well, you can see right here that this is now a perfect square. So I should have y equals x minus 3 squared. Because x squared minus 6x plus 9 factors into x minus 3 times x minus 3, or x minus 3 squared. Good? Now, here's the cool thing. I don't ever have to actually factor this. This will always be x, and look. Whatever I put in that box. That was the process that I used. That will always be that. So now I just have to look over here. I got a negative 16 and a negative 9. That's negative 25. And now, look at that. That's amazing, right? That is now in vertex form. And if that's a vertex form, then my vertex, let's go back to those other ones so you can see them all. My vertex is, right, the opposite of that one, 3, comma, negative 25. 3, comma, negative 25. So now I found my y-intercept, my x-intercept, and my vertex all from this problem. We'll definitely do some of those in class again too, so that you can see them, because you're going to need to see them more than one time. But hopefully this video helped you out on that. I've got one more little thing for you to be able to see in this, and we're going to go with our calculator on this. Turn that on. I'm going to give this a little bump here because there's a little glare on that window, so hopefully that looks really good for you guys. And I'm going to go ahead and put in y equals negative 0.08 x squared plus 4x plus 2. Okay, so negative 0.08 x squared plus 4x plus 2. And then I'm going to go ahead and hit graph. And you can see that it almost looks like a line, doesn't it? Right? Almost looks like a line, but if I check closely my y equals, you can see that I have a degree 2, which means this has to be a parabola. And then I kind of point out a couple things. One, there's a negative in front, and that negative means that it's got to open down. And then 0.08 means, means what? Means that it's really, really wide. So I'm going to go to my window, and I'm going to make this a little bit wider. So my x max, I'm going to put it out at 100 and see what that looks like. And then it looked like it was going up quite a bit. So I'm going to go to my y max to 50. So one more time, x max to 100, y max to 50. And I'm just going to hit graph again and see if I see a better window for this. Awesome. So now you can see a lot more on your screen. You can see I didn't need to go all the way to 100. I probably could have gone to about 60 and it would have been okay. But I do need to go a little bit higher. So I'm going to kind of tweak my window a little bit right now to be able to see those things better. So I'm going to go 60 on my x max, and I'm going to go 75 on my y max. And now you can see on my screen, I can see that perfectly. Okay? So one more time, I'll put this on the paper right above it, so you guys can see this. We were doing y equals negative 0.08 x squared plus 4x plus 2. That's that equation. And we're going to try and, we know, right? We know that this goes like this, whoosh, something like that, right? We're going to try and find all of those key points, where it crosses the x-axis, where it crosses the y-axis, and what its high point is from here. Okay? I'll straighten up so that looks good. Okay, so how are some of the things that I can find this stuff? What are some of the things that I want to be able to do? So the first thing I'm going to do is I want to find out its highest point. Okay? So I'm going to go second trace. Second trace is where I find a bunch of these cool things. So I got values, zeros, minimums, maximums, intersections. I don't have another equation up here, so I don't need to worry about an intersection. I want to find a maximum. So I'm going to hit button number 4, which is maximum. And then it says left bound. And what it's going to really do, it's going to say, hey, pick a value to the left of the high point. So I'm going to simply move my cursor over here so it's to the left of the high point. I'm going to hit enter. And on the newer calculators, it puts this nice little line up there. It says, oh, that means this is your left side boundary. Then I'm going to move my cursor, because at the bottom right here it says right bound. I'm going to move my cursor to the right side, right? And there we go. I focus that in a little bit. Hopefully that's even clearer. I'm going to go ahead and hit enter once I get to the right side of it. And you can see that the high point falls between these two lines. Again, the newer calculators show that, and I think that's kind of beneficial for you. Then it says, do you want to guess? And I'm like, I don't want to guess. So I just hit enter. So now this tells me that the maximum value is at 25. When x is 25, the maximum value is 52. Okay? So 25, 52. So if I go here, back to my paper, I know that my vertex is 25, 52. 25, 52. Now, believe it or not, and I'm not going to do it here, but if I did some crazy algebra right now, and I did completing the square on this messy thing, which you guys don't even know how to do yet, I would get it in vertex form and it would show up as 25, 52, even with that weird negative 0.0 right there. Okay? Okay, so back down to our calculator, and we're going to try the next thing. So on the next one, I want to find out, let's say this was a golf ball that I hit. So I know that after it went out 25 feet, it was 52 feet in the air. So that's probably like a sand wedge, and I hit that really high up into the air, and now it's coming down. I want to know how far it went. Well, I know that vertically it was someplace over here, and I can do two things. I can hit my trace key and actually scroll down. Look, it's coming down, it's coming down, it's coming down, it's coming down, and poof, it hits someplace right around there. And you can see that right now my Y value is 0.16, which means it's really close to the ground. Sorry, I just lost the light. There we go. So I want to find exactly what that is. So I'm going to hit second, trace, and I want to find number 2, a 0. Now I did this different before, so now I'm going to show it to you this way. So I want to find a 0. So I'm going to hit number 2, a 0, and it says left bound. So I simply move my cursor someplace to the left of it, and I hit enter, and then I move my cursor someplace to the right of where it hits the ground. I hit enter, and it says guess. Nope, I don't want to guess. And now you can see that it actually went out 50.49, and maybe that's feet, maybe that's yards, whatever it is for our units. Okay? So that was one way to be able to get that x-intercept. I'm going to show you another way right now and see if you like this better or not. So I'm going to do second trace. I'm going to hit 0 again. And in this case, instead of moving my cursor, I'm simply going to type a number. So would you agree like 25, which is way over here, is to the left of that point, which it is. So I can literally type 25, enter, and it'll put a mark at 25. I know that this is somewhere around 50-ish, right? So I'm going to go ahead and do 58. I don't want to do 100 because that's off my screen. And if I do a number that's off my screen, it will say there's an error right there and it won't work. So now I'll find wherever it goes through the x-axis between those 2 points. I hit enter, and you can see it shows up with the exact same number. Good deal? Now, what did I do for you guys before? And this is the last thing I'm going to do for finishing up with this. I'm going to show you that you could just go to y equals, type in 0 in your y, go ahead and hit graph, and now you can see on my calculator, there's the blue one, and then it just showed y equals 0, which is the red one. And now I can go to second trace, number 5, intersection, and I'm just moving my cursor over here because if I intersect the blue one with the red one, it'll tell me where it is. So again, 3 enters, first curve, second curve, guess, and it'll show me again 50.49. So those are all the ways that the calculator can do that, and hopefully you can do that too. I guess one last thing with this, every place along here is the x where it's increasing until it gets to the vertex, and then from there it's decreasing. So if we talk about an increasing or a decreasing function, that's what we're talking about. Increasing is all the x values for which it's going up, and decreasing is all the y values for which it's going down. Final thing on this one I'm going to point out for you is domain and range. I'm going to do that on a piece of paper here and then call this good on this video. So domain and range. Domain is all the possible x values. So if I look at this graph right here, and this goes on forever and this goes on forever, the domain equals all real numbers or from negative infinity to infinity, like that. And the range is the output of the y values. So you can see that there's y values way down here and all the way up to here and all the way up to here. But I'll ask you, is there any y values here on this parabola? The answer is no. So where does it stop? It stops right there. So the range goes from negative infinity all the way up to 52. Okay? So, hopefully this was beneficial to you, that you understood that. I know that was kind of a long video, but there's a lot of stuff in there. And remember, we're out of class more often, so think of every one of these videos is the same thing as if I was presenting stuff in class. The only difference is you're going to have to shoot me those questions as you go through when I do get to see you, or send me an email that says, hey, I really need to be able to get in a Google Meet so we can talk about it that way. Okay? Peace out. Talk to you guys later. Thanks.